products I'm going to speak about. This is the product portfolio I'm responsible for, and I briefly give you an introduction of these 4 products, but I will be focusing on the Postgres cartridge in detail. So JChem Base is a library. It's really useful for developers or programmers or war partners who are creating an application using this chemical intelligence to connect to relational databases. Actually, most of the well-known relational databases are handled, and it is on the market, I don't know, for 15 years now. So it is quite a mature product. The next one, the Oracle cartridge. The Oracle cartridge is, let's say, it's also a mature product. We can call it as an industry standard in the cartridges. But what is the difference between the JChem Base and the cartridges? The cartridges are extending the SQL functionality with additional functions and operators, which will help you to store and manage chemical data in a relational database engine. Actually, we have just the Oracle and Postgres cartridge, and both of them are extending the SQL language. When do we suggest for the clients to use cartridges instead of the JChem Base? So I told you that JChem Base is for developers, but if you have complex data structures like multiple tables in the database, which I joined together with different times, and you want to search among all of these tables with joint statements, maybe this is too technical, but the database administrators knows this, then we will rather suggest to use the cartridges, because in this case, the query planner of the Oracle database and the Postgres database can provide you the fastest execution plan for the given query. So complex data, the take-home message, complex data structures, please use the cartridges. Another advantages of the cartridges is that if you want to put all your chemistry into one place and then just interface it with different GUI tools, then again, the cartridges is a suggested solution. JChem Postgres cartridge that just released a few years ago, and I will speak about the latest developments on the Postgres cartridge. Web services is providing you the RESTful API interface for the JChem functionalities. And some things which are not mentioned here, but I will let you know right now, that we are also experimenting with Lambda functions, which is provided by the Amazon Web Services. We are also playing with Hadoop system, distributed Hadoop system, and then we are also trying to make a cartridge on the cloud. So if you are interested in this topic, then we can have a discussion on the boat or after the presentation. Let's go into the detail. What are the latest developments on the Postgres cartridge? To understand why are we developing things, let's see that what are the problems we have seen. So we see typically 2 types of workflows when using cartridges. One is an interactive search, when the chemists are sitting in front of a computer, they are drawing structures, they would like to get back the hits as soon as possible, and they will modify the query according to the hits that they observe. So they do it, and they would like to do it very quickly. Just we heard in the previous presentation that they don't even want to wait a second for that. So they want to do it very quickly. If you are not a chemist, then you can imagine this as you are sitting in front of the Google, and then you are searching, and then what you get back, you refine your searching based on the hits. The other use case is the workflow. I call it your workflow usage. When you have a lot of things what you are doing with your structures, then the first thing is that you are filtering your structure based on chemical entities from a database, and then you are calculating some properties on this function, and based on the properties, you do some clustering, and finally you get back the most representative molecules of the clusters. In this case, it's typically a longer process. In this case, then the searching is just a little part, and what you are changing is not on the search part, but the properties what you are actually calculating, or you change the clustering parameters and so on. But this is typically a longer process, and you are actually used to wait until the whole process is finishing. Okay, let's focus on the first one, the interactive search. What we provide for getting a better results in this case. The first thing we did is the relevance search. So if you are querying with hydroxycoumarine, then if you are not ordering your results according to anything, then the SQL is just pushing back the results as the system would like. So you get back different hits like this one, and yeah, the substructure can be notified that they are there, but I mean, probably this is not the way you would like get back the results. The way I think it's much more meaningful if you order the substructure search based on, let's say, similarity. We call it the relevance on the query. In this case, the hits are returned back based on the query relevance. It's, let's say, the similarity. And if we think of the two solutions, actually the hits are exactly the same, which means that these hits will also appear in this search, only the orders are different, and I'm just showing you the first 6 hits from the database. If you get it, then let's go a little bit further. Because what you can do with this technology, then you can do a hits as you draw feature. So you start drawing your structure, and automatically the first 5 hits from the database appearing on the right on the quick hits. And you will notice that in a case, not now, but while we are drawing this structure, there are no hits. What does it mean? Yeah, it can mean the algorithm is buggy, but this is not the case. But you have found a void space in your database. Sometimes you are not interested to this void space, but sometimes it just makes a note in your mind that, oops, I found some interesting thing. Maybe I can follow up. Maybe not right now on your project now, but it's good to know. And another thing which is very interesting in this video, if you go to a searching page, you find something which is very important for the searching, but you don't find it here. Do you know what it is? It's a button which has a label, search. This is not here. So we spare one click for you with this solution. Of course, to have this, you need something more, which is called speed. You need to have the data very quickly back from the database. And we are comparing the speed. We are comparing the speed with some etalon, industry standard, and we have chosen the Oracle cartridge for this industry standard because it was on the shelf. So comparing the speed of the Postgres cartridge with the Oracle cartridge, that's what I'm trying to present for you, is running on 8 million structures. Everything is in the memory. And what we're trying to get back is just the first, let's say, maximum 500 structures, which are provided back for you from the database. Why just the first 500? Because you want to do interactively and see the results and modify the query. I don't think you can manage by yourself more than 500 structures under a few seconds. I don't think you want to do that. So the first one, and okay, what I'm showing you on the x-axis, we provide the different searches. On the y-axis is the speed of the search, the returning of the hits in milliseconds. The green one is the Postgres cartridge, and the red one is the Oracle cartridge. And one you can observe that in case of duplicate search, but in any other case, the Postgres cartridge is much, much faster compared to the Oracle cartridge. The first one is the duplicate search. The second one is the similarity search for 80%, so more than 80% similar compounds. And you would like to know the number of hits which are returned. The next one is the top 100 with similarity 80%. And the last one is all hits with the threshold of 80% similarity. We can get these good results because we are not getting back all the data. Next one, the substructure search. So the similarity search can be easily improved. It was much more easily to improve, but the substructure search was a little bit harder. And what again we have here, different search types, but we have the limit here. That's what I was telling you, to limit the hits just for the first 500 substructure hits, but with the option of relevance ordering, what I was just showing you a few slides before, okay? So the hits are ordered according to the similarity of the query structure. We have different test sets, and that's what is shown here. And the final slide here is the comparison of joint search. This means that you have a structural search and you combine it with a non-structural filter query. Here is a mole weight limit. And here, if you join these queries together, we can, again, with the limit of 500 structures, and again, with the relevance ordering, very nice results. Okay, I was showing you till now exact numbers, but how does it feel? I mean, what do you get as a feeling? So, if you take the example of joint search for quite an exact structures with 500 hits, then it is coming back for you under 300 milliseconds, which means that you have to really stare your screen to see the results. The results are coming back because the blinking takes just 300 milliseconds. And do a substructure search on this 8 million data set is taking less than 100 milliseconds, which means that it can be a good game that someone starts the search, the other tries to stop it. Maybe this is not the right game, but I mean, this is showing some speed. Finally, we had just one little problem to solve. And that is no more excuse for coffee bake for searching. You should find something else for coffee bake.
You had plans last year that you want to eliminate the password you have to give over to the cartridge middleware server to connect back to Oracle. How far are these plans?
Actually, yeah, we had plans to do that, but actually we felt that these are more important, so we were going in this direction. We can discuss it, whether to improve the priority of these plans, but the things why we haven't started it yet was that the Oracle cartridge, typically to move the Oracle cartridge version from one version to the other is always what we are reported. It's always so painful for the users. So we just saw that we want to go faster and get feedback from these new features instead of doing something which is maybe good, maybe not good, but.
So what we saw is that the Postgres cartridge is much faster than the Oracle cartridge. And are there any plans or possibilities to speed up the Oracle cartridge in the future?
This is a perfect question. I was expecting this question. The answer is yes, if the user community needs it. So far, you were the only one who asked this question, and I was doing the presentation. This is the second time I was doing this presentation, and in the previous presentation, no one asked this. So we need some majority to say that, okay, we will do this, but we need clients who would use that. So again, the answer is maybe yes, we should see the market if the market needs it.
Do you have any explanation why it's significant? It's tremendous, the difference in speed, especially yes. For a large number of hits. So is there any explanation? Is this the Oracle
Yes.
overhead?
No.
Just technically curious.
No, it's just us. It's just us. I have ChemAxon has very good developers, and they figured out that if they re-architecture the backend engine, then they could get much faster speed. The only problem with the Oracle cartridge that is started, I don't know, 11 years ago or 12 years ago, and to do the same, it's not feasible. What you can do, they take the new engine and put it under the Oracle. That's the way how can we do it. But the old code is quite old, and it would make us much more time to change the old code instead of putting this new engine under the Oracle. So we will never ever get back the same Oracle cartridge. What we can get is a new Oracle cartridge. And maybe it's not a secret if I'm telling that we made also some step, and also the name is already done, is already here, and it's called Coral, thanks to Tommy. I don't know where Tommy is. So, oh, yeah, Tommy is there. So Tommy already made some steps in this direction, and we were experimenting with it.
So will we have similar performance for JChem REST services?
Oh, Virendra. If we put this whole engine under the JChem web service, then we will get the same performance. We can get it, yeah. Yeah, I see, you would like to have it.
Yeah.
So, okay, we have the development plans for the next 10 years.
Tomorrow.
Tomorrow, sorry.
Thanks. Yeah.